Hi all, I will walk you through SAP assignment 2, which is shopping basket analysis business scenario. I've given you the code for predictive analytics in case you need it. Let's look at the business scenario first. The Global Bike Incorporation marketing department has decided to explore the cross-selling potential for their products using a shopping basket analysis. The aim of a shopping basket analysis is to identify products often bought together. The marketing department aims to use this information to improve the product catalog by printing the identified product bundles together. So basically, shopping basket analysis will help you to find out which products a customer often buys together. For example, if I buy coffee, I will also buy bread 65% of the time. So this is the association, okay? So this is based on data mining association, which products are often bought together. It helps the companies in a variety of different ways to bundle products, to promote products together, to shelf products together, so on and so forth. Okay, coming back to this business scenario, as GBI is a wholesaler, it does not directly sell to end user customers, but rather to retailers. Therefore, GBI has no direct access to end user customers' preferences. An agreement with one of its major customers, Bavaria Bikes in Munich, has been signed. As part of this agreement, GBI receives all sales records for GBI products sold by Bavaria Bikes in the year 2011. In exchange, Bavaria Bikes receives a 2% discount on all ordered products for the forthcoming year. The sales data provided by Bavaria Bikes includes all products ordered from GBI in the year 2011, including product ID, purchase price, sales quantity, and the receipt ID. If a product has not yet sold, the receipt ID remains blank. Okay. The sales data is stored in a separate table in the HANA database. So if you look at this shopping basket data, look at the design view of the table. You have year, customer number, product, sales quantity, unit of measure, currency, purchase price, sales price, and receipt ID. The data types are either character, integer, decimal, so on. The dimension is the data size and the data column stored data type. And then the table here shows the data view, which shows the actual data. So to provide additional information related to the customer, which is Bavaria Bikes, and the product sold by Bavaria Bikes, an analytic view has been created on top of the provided table, which is called GBI Shop Basket. This view joins the shopping transactions with corresponding master data tables. So you can see the analytic view here of the shopping basket. So what is your job? Your job is to create a shopping basket analysis on the analytic view shown above in order to identify products frequently sold together. So for this task, you will use the tool SAP Predictive Analytics. The appropriate algorithm you will use is known as the well-known a priori algorithm, which performs an association analysis on your shopping basket. The result of this analysis is a set of rules which indicate the products often bought together. Okay. So basically we are using the famous a priori algorithm within predictive analytics to perform association analysis. What is association analysis? Association analysis tells us about the products that are often bought together. Okay. So in order to start predictive analytics, I open here. Okay, see, it's asking me for the code. So I have given you the code. So type in the code, save it. Close. Okay, come to Expert Analytics. Click on Expert Analytics. Okay, so go to File, New. From here, connect to SAP HANA. Okay, next. You have to specify the server. This information will be given to you by your instructor. Okay, it will be given to you by your instructor. I am using my own information. Okay, now I have to find GBI demo shop basket. Okay, so I have here GBI demo shop basket AV. So GBI demo shop basket. Okay, and then I create that to load that database. Okay, to load the data set. Okay, so now you can see all the measures. Measures are quantitative data, purchase price, sales quantity, and then you see the dimensions. There are 16 dimensions which are descriptive information, and they are all here. Okay, so I'll go to the table. Okay, and then in the table I will add receipt ID, to the dimension. So receipt ID is a dimension, so I'll add it to the dimension. Okay, then product is a dimension, then product name, that is also dimension, and then measure is sales quantity, which is a measure. So I add all this. So you can see that you have the table with the data. Okay, so now you have to analyze the data and open a Word document and answer the following questions. The questions are here. The receipt ID is empty for the first couple of rows. How do you interpret this fact? If you go up, while you were looking at this, it was told to you, see, if a product has not yet sold, the receipt ID remains blank. So here, when the receipt ID is blank, that means that receipt ID is blank, that means that these products have not been sold. How many pieces of the repair kit have not been sold? This is the second question, and you have to answer these questions in a Word document with the screenshot. So when you answer a question, you have to justify your answer, validate your answer with a screenshot. So how many pieces of the repair kit have not been sold? Okay, so I have to look at a blank receipt ID, because if it is blank, that means it hasn't been sold. So repair kit, you can see that 8 items were not sold. Okay. Similarly, which products were sold under the receipt ID 2011 and all those numbers? So if you can check it out from here. Okay, so check it out from here, which products were sold under the receipt ID. For example, if you ask me which products were sold under the receipt ID 173, I would have told you elbow pads, knee pads and men's off-road bike were sold. Okay, so give similar answers. So this is your analysis of the table data. Then what we will do is we will apply the a priori algorithm. We will use the receipt ID to find out which products were sold together. Okay, we will set the measure of support to 0.01. In this way, the algorithm will show only product sets that occur in at least 1% of all transactions analyzed. Furthermore, we will also choose 0.5 as confidence to show only rules with this confidence level or higher. Okay, so in order to do that, we will go to predict. Okay, from predict, within algorithms, I will choose HANA a priori. Okay, then I will double click on that, and then within that I will use the column name is product. Okay, transaction column is receipt ID. Remember, I'm finding out the association with the help of receipt ID. Then my support is 0.01. That means at least in 1% of the cases it will be analyzed, and then confidence is 0.5, and I'll do it. And then I will add the data writers here. So I will add HANA writer, and then when the scheme name will be GBI 132. This is mine is 132. So you give your own name, okay? And the table name will be basket results. Okay, and I overwrite it if it exists because I have practiced it before. Okay, so I said that. And then I will run the analysis. I'll say okay. Okay. Next is I have to analyze the results and interpret it. Okay. So the question is, what rule has the highest support? So if I look into this one, 0.07, this has the highest support, right? Because 0.07 is the highest number. So what does it say? Pre-rule and post-rule. It basically says that this has a support of 0.07, which basically means that in 7% of the transactions, ORWN1100, which is basically women's off-road bike, and that is bought together with men's off-road bike, which is ORMN1100. This lead to the assumption that couples often buy this combination of bikes. Okay, so this one and this one, these two are often bought together in 7% of the transactions. Okay, the next is, what rule has the highest confidence? So if you look at the confidence, this rule has the highest confidence. So what is this rule? This rule, highest confidence of 1 means that in 100% of the cases, E-pad and K-pad are bought together. So E-pad is elbow pad and K-pad is knee pad. So in 100% of the cases, elbow pads and knee pads are bought together. Okay. So now I have to do the association chart. So I click on here, and so you have to find out the most prominent rules. You can see that this is the most prominent rules here. The E-pad and K-pad, they are bought together. Okay. So give your answer with a screenshot, and then you need to save your work. So I just come here, save as, and in the document I write down a priori, and then mine is GBI 132. You use your own document, and I just save it. Okay. Now, using the HANA writer, I have written the results into HANA, and in this step I will check to verify that the rules have been written successfully into the database. Okay. So what I will do is I will create a new document in SAP Predictive Analytics. So I'll come here, I'll come to new, I'll connect to SAP HANA. Okay. Once again, your information will be given to you by your instructor. So you use that. I'm using my own information. And then I will go for basket results. I will search for basket. And I will take it from 132 because I'm 132. Okay, you take it from your own. And then I'll click create. Okay. So I'm in the visualize tab, and then I will create the table, and in the table, in the dimension, I will take pre-rule, post-rule, support, confidence, and lift. So it basically looks the same as my prior table because I can see that confidence 0.7, and then a confidence 0.1 for E-pad and K-pad, and 0.7 for those men's bike and women's bike. Those things are the same. So the question now is, do the value displayed in the current table match those from the a priori analysis earlier? The answer is yes. Now, this is your assignment 2. So what you have to do is, you have to give me the answers of all the questions asked in the assignment, and the answers should be supported by screenshots. Okay. So that would be it.